Thank you. And thank you. And I suppose you are not all familiar with geology. Not so very much. I will talk something about the ground. Do you know this is one of the protection boundaries when we are putting down the waste from the nuclear power plants into the ground. We are putting it down into solid rock. For instance, like this. This is a piece of granite, which I have brought from Espe. From the Espe laboratory. But this is not the one you will see when you go down to the tunnel, but this is one of these pieces. This is a granite, and it contains a lot of different minerals. So we have a lot of different rock types, we have a lot of different minerals, and they behave different when we heat them up, if there are cracks in it, because if there are cracks, there can be water. And we heat up the water, the hot water will try to penetrate the surface. And then we will put the radioactive waste, the nucleus, into the biological sphere. And then we can eat it. And we have the circulation of nuclear in our bodies. So this is one of the boundaries which they have been talking about yesterday, I think. You know, there was some copper lining, we had some rocks, and a lot of different things. But when I tell you about this one, this piece of stone is 1,800,000,000 years old. Can you imagine what that is? How long this one was created? Somewhere down deep below us, melted stones, like magma we call it. And then this magma cooled down and the minerals started to crystallize. All minerals have different crystallization temperatures and crystallization pressures. So that's why we have a different, so that this is not only a big mass of everything. Inside this one, you are sitting in there close to me, you can see there's some white dots, there's some red dots, and there's some black dots. And they are different minerals. And they behave different when we heat them up. Someone tried to blow everything away because they are expanding more and faster than other minerals. So that's why we have to have control of what type of rock and bedrocks we are looking at and what we are putting down the waste material into the ground. 500 meters down, the Swedish system is trying to store down this waste material from the nuclear power plants. And they are doing so. This low radioactive waste is put down up in Forsmark, a bit north of Stockholm, on the archipelago of the Baltic Sea. Down there we have one storage for this low active radioactive waste. And you were on Monday, you were looking at the high radioactive waste in these basins of water 30 meters down at the power plant area. You've been there?
Yeah.
Yeah. It's nice to see it. Mm-hmm. All the waste from Sweden is concentrated to that place. And then we're going to do some capsuling around it and put it down into the ground. But 1,800,000,000 years old is this rock. And can you imagine about, when we say about how long will these storage facilities stand against the nature forces? Because nature is not stable. It is always going in circle. You know, we have an inland ice for about 30,000 years ago, and for 100,000 years ago it was about 3 kilometers of ice here in Oskarshamn. It was very heavy and it was moving down south from the north. And during the The past 500,000 years, you know, this 500,000 years, we have had 4 different inland ices in this area. Each of them are about 100,000 years. That means that the normal situation here is inland ice. This is just a small intersection between different types of inland ices in Sweden. So we have to consider about what will happen to these storage facilities. And we say that it must be safely stored during about 100,000 years. But how long is 100,000 years geological sense? I have brought a small rope. So if, Vaclav, if you are going to have, okay, you can have this one here, yeah. You can just stand up here and hold this one here. And I will hold this one here. This rope is 4 meters, 600 centimeters, 4 meters, 60 centimeters long. And you know, the age of the Earth is about 4.6 billion years.
Like a half lifetime of uranium-238, remember that?
This is, yes. So this is 4,600 millimeters. It means if this is the age of the Earth, every millimeter here is 1 million years. Yeah. And we are going to put down the waste to be safely stored in 0.1 millimeter. And what will happen to the Earth during all these areas? We have had mountain ranges, we have different types of oceans, and mountain high, river deeps, everything is going, and you are circulating like this. So 0.1 millimeter, that's what we are planning to have a safe storage system. And I'm quite sure that the Earth will continue at least a couple of million years, a couple of millimeters more than this one. You know, the dinosaurs, they disappeared from the, we think it very far away, they disappeared here, 6.5 centimeters, 65 million years ago. That's the border between Tertiary and Cretaceous area, 65 million years ago. So this, when I say that this stone is about 1.8 billion years, it was created here. 25 kilometers down in the Earth, below the Earth's crust. How the hell could it come up to the surface? It was created down there, 25 kilometers. During this time, these 25 kilometers, the rain and the snow have been falling on it, and it is dissolved into small species, sands, gravels, ions, and they will go out into the sea. So, and in the next year, they will create a new rock type. So all these old rocks, they will weather, they will be transported, they will be deposited somewhere, and they will create new rocks. And that is the way life is going on. This is the life of rocks. They're very interesting. They are a bit longer circulation than for the Swedish people and for your country people and so on. We are living for 80 years. It's not like a dust here on this rope end. I just blow They're all people away from the surface. Thank you very much. So this is but just a small thought about what we are discussing, and to put it into a relation to the geological sense what we are thinking about. So this is just one thing to think about. So this is a picture of Sweden, the northern Europe, for about 600 million years ago. You know, "60 centimeters." That's right. There, we have. I took this picture there. You know. Then the northern Europe was the ground into a big sea. So, and on this sea, in this sea, there were swimming no fishes, because there were no fishes at that time. Probably some small creeps, which we can see on Saturday when we go out to Öland. We will see them in there. They call it trilobites. They were crawling down on the bottom of this sea. But this is what we geologically call the Cambrian area, Cambrian situation. This is North America. Is it the equator? It was rather nice weather, tropical. If we have had some trees, there have been rainforests, but there were no trees. This is Greenland, Siberia, Kazakhstan, Australia, over there. This is India, and this is Africa and South America, and this is the Sweden is here somewhere. And we are going down to the South Pole.
Olga is regretting that Siberia didn't stay there where it is now.
No, no. So Siberia was another separate continent. North America and Greenland was one, Africa and South America were one continent. How can we know this? Is this just my imagination, good drawings and so on? Could be, but we know that when this stone is going to be mineralized, going to be a stone, there are some small minerals in this what we call magnetite, and magnetite is you know, this is a magnetic stone. I can put it like this. Probably it will somewhere. You can feel this. Yeah, this is magnetic.
Yeah.
Oh yeah, yeah. You can. Thank you very much. I will give you a special ways after this one. So when these magnetic minerals are going to crystallize, they will turn into, because they are elongated, and they have a north and a south pole in these minerals. So when they come up to the surface, they feel that we have a magnetic field around the Earth. So they will turn into north and south. And they will turn to this dipping. So we can see where this stone was born. Then we can imagine that we have a volcanoes eruption here, we have volcano eruption here, we have volcano eruptions during this period. So then we can follow these continents going around everywhere on the surface of the Earth. And this process is still going on. So Northern Europe is going north by 1 centimeter every year. This creates tensions in the rocks. Of course it must be. And we have a lot of earthquakes around the world. We all know about this one. In Sweden we say it's very stable, but we are moving. But Africa is moving 2 centimeters every year. So you can imagine in a couple of years, but a couple of years there will be no Mediterranean. Because Africa and Italy, Spain, Portugal, Greece, they are connected to the north of Africa. And they are pushing us up. In 150 years, Scandinavia will be up at the, not at the North Pole, but very, very similar to that. Novaya Zemlya. Look now, you know, north of Siberia. So this creates these tensions which we are afraid of when we are going to put down the waste, because this creates a lot of fractures in the rocks. So we are going this direction. No, wrong. In east of Scandinavia we had huge mountains, we know. And these mountains, this is from the Rocky Mountains in Canada. These mountains, they were weathering, you know, mechanical weathering, we call it, the exfoliation, this is a special word for exfoliation. And these pieces of rocks falling down created some chemical weathering. So this chemical weathering created some ions, some gravels, some sands, and they were transported through in huge amounts of streams. You know, we once calculated about this Yellow River, what is called Yangtze.
Yes.
Yangtze in China. We were calculating.
Yellow River, yes.
Huang. Okay.
Yellow River.
Yellow River, yeah, Yellow River. We know that every cubic meter of the Yellow River contains 600 kilograms of particles. So every single cubic meter of water going out into the lake, the sea, bring 600 kilograms of very, very fine-grained sand. And how big is the river? Yellow River is 1 kilometer wide. Oh, let's say for easy to.
Depends where.
It depends where. Yeah, but 1 kilometer and 4 meters deep. That means 4,000 cubic meters, and this will continue every second during the year. 1,000 cubic meter times 600 kilograms. You can imagine how much of the earth crust is transported to the seas, creating these delta areas. Because when the streams is coming out into the sea, the transportation speed slows down, and the sand and the clay material will settle down and create new rock types. So from this granite up at the Esper laboratory, we will create stones like this. Probably a sandstone or something. This is a conglomerate. Created here down. So from this one, and this will take about 1 billion year to tear this one down to create a new rock of sedimentary rocks. But this is a process going on, and this is how the Earth is looking. We think it's a round one. How many of you have seen that this is a round body we are living on? Good. Have you been out in space? No. But we think it is so. You know, in England there is an association. If you are going to be a member of this association, you must consider that the earth is flat. Of course, if you are sitting there in an armchair and you are walking from the armchair to the pub, this is rather flat. So it's flat. But we all know, we are more clever than Englishmen. We know that this is the earth, the outlook of the earth. We have a core. This is the solid core in down here, and we have what we call a mantle, and we have the surface, which is only 7 kilometers or about 50 kilometers wide, the Earth's surface. That's why we are living in that. There we are building our houses, and there we are building our storage system facilities for this waste material. And you know, even if this is in Swedish, you can understand that this is the surface, and there's the house, the Esper laboratory, and it's drilling down, and we have about 1,000 centigrades just in the border here, and the density of the crust is about 3,000 kilograms per square meter. If you go down, we have a lot of temperature for 4,000 degrees Celsius down here. This heat is very important. This is magnesium and iron silicates. You don't know what a silicate is, but this is a silicon-oxygen combination with magnesium and the iron. This is very, very common in this one. And down in the core, we have iron and nickel. This is what we think. And this is a fluently core, and this is a hard core down here. And how can we know that? Well, if you are blowing in a big atomic testing, we have some energy waves going down, and some of these waves cannot penetrate fluid material. And when it comes to different types of lines down here, we have some refraction. So we can calculate that it's mostly like this. And then we have some meteorites coming down from the surface, and we also know that they contains this material we have here. So that's why we are calculating about this. The surface contains about, this is oxygen, this is 46.7%. This is silica, alumina, iron, calcium, sodium, potassium, and magnesium. So 8 of these elements contains 98.5% of the Earth's crust. It's not so much. So then we have some different things also, like iron and gold and silver and uranium and so on, which we are mostly interested in. If we have been interested in this, there's been no problem. There's a lot of them, but yeah. So this is what we call SEMA. That is the crust beneath the oceans. This is the bottom of the oceans. This is a hard black stone. Hard black, yeah. I will put them here so you can look at them. This is what we call a basalt. This contains magnesium and iron silicate mostly. Magnesium, iron, and calcium silicate. This is one. So this is what we call this. We can see on the bottom of the sea. You can see that this is a sea. There's a fish down there swimming in the sea. And this is Seal. That is the continent. That's the granite. And the continent, the density of the continents is about 2.7, 2.8. But this one is 3.2. So this is more heavier than the continents. That's why the continents is fluent. What do you call it? Flyter. Flyta.
Flowing.
Flowing on this schema. Okay. So when the heat is coming down from the surface in the core, it goes up because heat is, if you are heating up material, it will be more lighter than the cold one. So it will go up to this surface. And when it comes up to the surface, it will tear the surface apart. And it, from different places, it will tear this surface apart. And then there will be a collision somewhere in between them. And this is going to create new material which is coming up from the bottom here. So if we are looking at this, this is what we call a rift zone. Rifting is a process where the hot is coming up, bringing some mantle material up into the lakes, sea, not lake, sea, and we are spreading along. Then we will have some fault zones, because if we are tearing this one apart, there will be some fractures. A lot of fractures everywhere. The East African Rift Zone is one of the most famous ones at this moment, at the Earth's rift zoning. And it's, it is from the, if you go from the African Horn down to Kenya, Tanzania, Mozambique, we have this zone, this rifting zone. And this is will create a new continent, the East African continent, in a couple of years, couple of million years, probably.
Tommy, can we have a control question? Who knows where does the heat come in the nucleus of the Earth?
Okay.
What is the source of the heat? Because Tommy was talking about the liquid and hot center of the Earth. Where does this heat come from? Who knows? Yes, Jeff. That's mainly, yes, it's about 40–45% of this heat is coming from actually naturally decaying isotopes of uranium and thorium cycles. So this is this slow, it's mainly alpha, by the way.
Yeah.
It's this long-lived radioactive materials which are actually ensuring us that our...
What is the half-time for uranium?
Oh, I told you already, 4.6 billions years.
Yeah.
And for thorium, who remembers? 14, that's the age of universe,
yeah.
14 billion.
4.6 billion, yeah. That is the age of the Earth. So probably we will have some another 4.6 billion years, at least, living here, if we are going to stay alive so long. So this is what we call a hotspot. One of the most famous hotspots, not only a rift zone, but only a hotspot, is Hawaii. You know, if you are looking at this ocean, vad heter Stilla havet? Stilla havet. Pacific Ocean. If we are looking at the Pacific Ocean and you're looking at Hawaii, you can see that there are some old Hawaiian islands. I will try to draw this. Here we have Hawaii today, and if you are looking, this is north, and here's the American border. So Hawaii is here, and this is why the Pacific plate, this is one of these continent plate, is moving like this. So that this was for about 200 million years ago, this dot here was there. And now it has moved. So now the next Hawaiian mountain volcano will come over here. And it is we can see it down at the bottom of the Pacific. So that's why, you know, the bottom, the ground is moving, but the hot spot from the from the core is the same position every time, so that the surface would go like this over here. That is also interesting here. This is what we can see. The volcanoes, we come up from the bottom of the seas and rise. Then this is what we can see from this is from Mediterranean.
Itna?
No.
Sofia?
No.
The other one.
The other one, where Ingrid Bergman was playing an old. Oh, you are not so old, so you can imagine.
Well,
Ingrid.
what is the name of this volcano? You should know. She's Italian.
Yeah, okay, but I don't know. I don't know that.
Stromboli, yes, it's Stromboli.
No, Stromboli, yes.
Stromboli, yes, Stromboli, yes, yes.
Stromboli. Yes, if you go by boat from Naples down to Catania, you will pass this one. So this is Stromboli, and it has a volcano eruption every 5th minute. So, and if you go there during the night, you can see that this is a nice color of red dust coming up every 5 minutes, going up there. It's great. Also, big rift zones is penetrating because of this rifting along this. I'm sorry that to this one. This is not a rift zone, but it's almost like it can look like this one. Great Glen Fault. You know, in this lake we have Old Nessie. This is the
monster.
This monster in this Scotland lake, yes, living here in this one. But this is the Great Glen Fault. So I have seen the monster, but it was no, it was not in
subject during the summer for the newspapers when they have nothing to write. Yes. They write about Nessie.
This monster Nessie, yes. But you know one place we have that where the plates is going to crush into each other, and there this bottom of the lake, this black one is coming down, and this is the continent. The continent is not so heavy as the black stones, 3.2 grams per cubic centimeters, so it will go down. This is what we call subduction zones. We have a lot of subduction zones along this Earth crust. But if we go down here, we are creating a big, you know, when stones are coming close to each other, I have to do it like this. This is the black stone and this is the red stone. But when the stones are coming and they are trying to move along each other, they will stuck somewhere, and there will be a very, very big tension, very big forces along this one, and sometimes these forces are too big and we have a slip. And then we will have earthquakes in these areas, and if the earthquakes is up here, they can create tsunamis. But if they go down here, this is what we have in Nepal. Then we crush all these houses up here. And this is creation. This is going on every second during the year. I think we have about 500 rather big earthquakes every day along the surface of this crust. This is what I started to talk about, the weathering. The weather is going down to weather, and we have some streams, and we have the deposition here, and we are creating a fossil. If the fish is dying and go down to the bottom and the sand is covering him, he will stay there for several million years. Yeah. And also new volcanoes from Italy. Again, this is Vesuvio. And this is the big city of Nepal.
Napoli.
Napoli. Okay, Napoli.
Naples or Napoli.
Yeah, Napoli. And you see that it is very, 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 very close to this big volcano. And this volcano, we have the old town is located down here. So I will give you some picture of this one. Pompeii was located very close to the new Napoli. And then the lava will pour out. And we have this one. This is a fresh, I told you this one was 1.8 billion years. This is from 1981. I put it here, I took it here when it was still hot. It was very nice. This is Iceland. And we had the youth hostel is right over here. And when we woke up this morning, we had a new lava in the garden. It was very, very exciting for us geologists being there. Very nice. So this is one from this piece, which is the new art. It's very nice. It's good.
Don't put it to the place where you have a lot of silver.
No.
So yes.
No. But it's very interesting. You see, it is just on the grass here. So it was nothing. We have one friend up here, but he had to change his rubber boots because it was so hot. So they melted in the bottom when he was trying to walk on this one. And the surface was only 1 centimeter thick, and under there it was fluently magma. So nice. But they also have ashes from this area. And ashes is not so good for people living in houses like this. And you know, volcanoes on Iceland sometimes disturbs the aircraft going around the world, because we are not interested to have these ashes into the engines of aircrafts. It's a lot of but we cannot do anything about this one. And it's a lot of carbon dioxide coming out from these volcanoes. Huge amount of carbon dioxide. But we cannot do nothing about it, because this is the situation on Earth. This man, he could not run away because he was sleeping when Pompeii had a disaster, when the Vesuvius had this ash fall. And he was not killed by the ash, but he was killed by not having any oxygen. Because when the ash was coming, this ash was glowing. It was glowing, you know, and it consumed all the oxygens in houses everywhere, so that people died couldn't breathe. And he was burnt, but you can see we put in some gypsum. Not we, I didn't do it. No, the Italian archaeologists, they knocking on this hard rock like this.
Part of our students look like today, tomorrow morning, you know.
Yes, tomorrow morning. Ooh, yeah. Yes, you know, they were knocking on the hard rock, and they found that there be some some holes in this one, and they put it in some gypsum, and then we could see that we saw that this was a man. We could see that. We also could see that what type of clothes he was wearing, but he was still in. And then we can see that there are some dogs, there are some horses, there are some different types of a lot of people were killed during this eruption of this one. So it's very dangerous about this one. But if you ever go to Italy, go to this time. I was there a couple of years ago, but Pompeii is always on the top of my list to go and visiting. It's very, very interesting. So this you have seen. So if we just go 400 million years ago, you see that Sweden has been down here, and it is now coming up to the equator. We are staying at the equator. And this is why we have some inland ice in the Sahara Desert. We can see tracks for an inland ice in all these deserts. And we think, how could that be? Because Africa and South America were down here at the South Pole during this time. And then for a couple of years ago, 200 million years ago, we had something what we called it the Jura. You have heard about the Jurassic Park. This is the period in Earth where we have these big animals living on Earth, and they were these dinosaurs were living, and they lived from 200 million years and to about 65 million years ago. And for 65 million years ago, they were killed, and we are not sure exactly what happened, but we think it was a big meteorite entering the Mexican Gulf, somewhere there, and it created such a big dust that it was going to be cold, and so that they were a lot of diseases and so on. So there were some virus going into the animals, and also pardon?
No sun exposure.
No sun exposure, so that there were a lot of much less of this eating grass for them, and there were also, we can see that this for 65 million years ago. Okay, this is today. 65 million years ago, we have a border between Cretaceous time and Jurassic Tertiary time. And this is a clay border which we can find a line all over the Earth. And I've seen it down in Lublin in Poland. I've been visiting. It's a 1 centimeter thick layer, and it contains a substance which is called iridium. Iridium is almost the same. It has properties which is very similar to mercury, and mercury is not so very good for animals producing their children by eggs, because mercury creates very thin shells of these eggs. And you can imagine if you have Tyrannosaurus rex, Tyrannosaurus rex, Tyrannosaurus rex, about 2 tons, and he's going to sit down on his eggs, her eggs, and they are too thin in the shells. They will smash down, so that there will be no new ones. So there's a lot of factors creating this disaster, but we are thinking that this will happen again. Next time it's our turn to disappear from the Earth's surface. So do the best of your time here, because this is what we are going to look about if we are continuing with this plate tectonic. Scandinavia will be up here. Africa and Asia and Europe is going to be there. Southeast of Africa will be a new continent, as I told you. North America and South America is probably there. Antarctica, and they're probably the same area. So this is how it is going to look in 150 years from now.
So it looks that Europe, Africa and Asia are most affected by this.
Yes, it is. This very so. Yeah, I think it's a good opportunity to find another planet. So this is also one of these lovely places you can go to if you are a geologist. This is a lava stream which has come through into another older lava stream which is there, and this is very nice pillars, and we can see this. Have you ever heard about something which is called Hell's Gate? It's on the Northern Island. You can go up to Hell's Gate, and this is hexagonal areas and big pillars of this one, and it's extremely nice to see this. And this is from the hybrids out in the Atlantic Ocean. So you can go there and watch birds, but you can also watch some different type of rock types in there. And this is the first. I will see if we have. I think you must.
Well, we take a break, yeah.
Yeah, I think you will have a break.